FastDataStacks is an OPNFV project aiming at integrating VPP in OpenStack for NFV purposes and using this model-driven approach that was described before by Maciek and Maros. Basically, what we see is that in the frame of NFV, we have been thinking a lot about orchestration, performance, blah, blah, blah. But what we see today is that the foundation is not very solid, because you can have like many good things here. If your network controller and forwarder is not good, it will be difficult to achieve good performance in NFV. Okay, so OPNFV is a project under the Linux Foundation umbrella, and OPNFV it's basically bringing OpenStack to build a solid NFVI, Network Function Virtualization infrastructure. Today, in this NFVI, people are mainly using OpenStack with ML2, but it doesn't bring all the nice features we have talked about in terms of two-phase commit and in terms of Youngification. And what we believe is that in the frame of OPNFV, there is probably room for something a bit more, a better model where you have, a controller driving different kind of technologies. Could be VPP, could be OVS, could be others. Of course, here I will talk a lot about VPP and Honeycomb, and bring that to OpenStack. So that's the goal of this FDS project. So FastDataStacks is a project aiming at integrating VPP in OpenDaylight, and OpenDaylight being integrated in OpenStack. All of that being driven by Young, netconf, and so on. And that's something we believe will provide good performances, and beyond performance, it will also bring stability thanks to this two-phase commit that we were speaking before. So that's what we want to do, integrate VPP, OVS, other routers in ODL, and integrate that in Neutron. So OPNFV is a project where we define scenarios, and these scenarios are then express some requirements so that we can do some upstream development in OpenStack to make sure that OpenStack become good enough for NFV applications, which is not the case today. So that can be using different hypervisors, that can be done using different controllers. We want to do that with OpenStack, then there are several install tools that can be provided in OpenStack. But here in the frame of of the FDS project, we really want to work on a forwarder which is VPP, and in the next release of FDS called Colorado, we'll have VPP support. By the way, for the next OPNFV event that will take place in June in Berlin, you will have a detailed presentation of that as well. So the FDS project, it's really taking different kind of controllers. So same controller, it's OpenDaylight, but that can be for L2 and L3. The choice is OpenStack, and here is the install tool. And we see different contributors for this project. So Cisco, Red Hat, Pantheon, Maros is from this company, Intel and Huawei are the main contributors today. So let's have a look at the stack that we are trying to integrate. So everything starts in Neutron, as you know, when it comes to OpenStack. And then Neutron issues some REST calls to the northbound API of OpenDaylight, so the controller. So here there is a specific project called networking, called Neutron networking. I don't remember the name, but it will come after. It's a project in Java that is able to receive REST calls coming from Neutron. These calls are then converted into GBP, which stands for Group-Based Policy, and we convert these regular calls into Young models using GBP Neutron mapper. And then we have a VPP renderer. So GBP which is a given policy-driven model, converts these configuration requirements into two different things. One is a VPP renderer that you can see here, and of course that will go through Honeycomb that was just presented before. And besides that, we also have a topology manager that can distribute various states across different distributed Honeycomb agents. Typical example of that is if you want to put in place VXLANs, you will have to deploy different configuration points to different agents, and that was this topology manager will do using the virtual bridge domain Young APIs. So that's really this complex stacks which is deployed, and here you find the VPP, the Honeycomb agent that sits on the compute node side. So that's really what FDS does. So if we go into more details, it's a typical workflow. So Neutron generate port creation. This port creation will do a GBP endpoint. Are you guys familiar with GBP and endpoints and this kind of terminology? So group-based policy is a way to do model-driven management, and instead of having imperative order being given to the data plane, you are able to manage your endpoints with groups of endpoints, and then you describe rules and contracts that are applied between these endpoints. So that is what is being done by GBP. Then GBP converts that into this VPP renderer and topology manager, and this is where you see this Young netconf calls that were described before. So in terms of delivery, in the near term, so we will have in July a first demo of that will be showcased in Cisco Las Vegas. So that's the first thing. Not everything will be provided in July, especially the layer 3 features like NAT, floating IP, and security groups will not be demonstrated in July. That is something that will be available for the Colorado release that will arrive in September. So that's something we will also improve the support for NSH in the meantime between July and September. So we are on it, and so you will see a first integration of VPP in OpenStack using Open Daylight in July, and then that will be completely released in September. Now, we have another integration scenario we are currently working on, which is more simple, but which is less powerful because it is not Youngified and doesn't provide this two-step commit approach. So we are working on this, and here it's very basic. We have an ML2 agent which is running here on the compute node, and you have a mechanical driver sitting on the Neutron server, and the communication between the two is being done using regular HTTP REST API. And what it does is basically when Neutron wants to create a port, it will communicate this information to the right compute node with the right information, and that will create a vhostuser port. So this driver only supports vhostuser. There is no historical driver. So that's really fast, but that's more limited. And that's something where the first, so this is a GitHub for the project here. So we are working on it. We have been working with our friends of SixWind on that, and we are currently developing that with Cisco resources. But again, anyone can contribute. This is a GitHub. There is a launchpad for the networking plugin called Networking VPP. So it's not yet an OpenStack official project, but that will probably become soon. So this project will be showcased as well for Cisco Las Vegas in July. It will provide basic VLAN support, and that's it. No advanced things like VXLAN. So that's really for NFV. So VXLAN is not something very important at that for this first step, and it will only support vhost user for fast communications. In September, we will add security group support and VXLAN support, as well as a compute node discovery mechanism, because in this version, all these compute nodes have to be listed in the ML2 mechanical driver configuration file. So that's very basic, but this is a step-by-step approach. We really want to have something working and something simple, and over the time it will grow and add more features. So basically, as a summary, I would say we have two projects, one which is using this young netconf controller approach, and another one which is more basic, providing easy integration in OpenStack. So these are these two projects to integrate VPP into OpenStack as of today.